In this video, I'm going to show GPT-2 inference. Whenever you type something into ChatGPT or a similar learned language model, the things are broken into tokens. The tokens go into the encoding, which turns them into token IDs or numbers. Like this one is called the beginning of sequence token. It's, as you can see, it's 50,256. So this is combined with the other tokens and put into a list. And so it would say, at the beginning of the list, it would say 50,256, comma, and then the token that represents, just say the word the, comma, and then if golden is the next token, then it would have the number representing that, the token ID, and so on. So then all that's packed into this generated box is one way to think of it. So then that box goes into here and it's unpacked and converted to a tensor and placed on the device like a GPU or a CPU. Then the results of that goes into the raw forward function, which is up here. Raw forward function is right here. So this is the input embedding plus a positional embedding. These are the pre-trained weights for GPT-2. And like just say if the first token, the word the, is represented as, just say the number 42, then it'll grab index or row 42 out of this word token embedding weights matrix. It'll grab row 42 out of there. And then this will be the beginning row from the word position embedding weights. And they're both the same length, the sequence length. So in this case, it's 768 is the sequence length, or the D model, as it's called here. So then they're element-wise added together, and the result is still 768 floats. And so we could picture that's packed into this X box, pun intended. So this X box goes down here, and it passes into the layer normalization, which basically squishes the numbers so they don't get too big. That's one of the useful cases of the layer norm. And then the output of that is passed into the, or is matrix multiplied with the weights of the queries, keys, and values. And the query key values biases are added as well. So the result is still 768 length. It's a vector of floats, such as B float 16 or float 32s or float 16, etc. And it's, once it goes down here, it's converted into the attention heads so that each head can process different parts of the concepts and so on. And then it goes through the masking for causal attention so that it can predict the next word but not see what the answer is while it's predicting. Because if it sees the answer, it'll already know what the answer is. So that's what the masking is for. And in here is the equation for the attention mechanism. It's the queries matrix multiplied with the keys transposed. This is transposing the second to last part with the last part, and it's dividing by the square root of the dimension head. In other words, the square root of the 768 length. So once it comes down here, then it's converted back to, it basically concatenates the stuff back together after the attention heads so that it's one long vector, 768. Oh, this other is it may split into, it splits it into, I believe it's 64, which is, if you look up here, it says 768 divided by 12, or the D model divided by the number of heads, and that creates the head dimension, which is 64, a length of 64. So then that converts back to, right here, it converts back to the length of 768. Then when it comes down here, it adds the residual stream to this, and after this is matrix multiplied and the bias is added to it, it adds the residual stream. The reason it adds the residual stream is there are several reasons. One, it helps prevent vanishing gradients whenever the thing learns. And the vanishing gradient problem is that some of these numbers can tend down to, or push down towards 0. And when you chain derivatives together, you multiply them together. So if you multiply a number by 0, then the result is 0. So if you add something to it, it makes it not 0. So that's part of what that does. And it's also less compute because the neural net doesn't have to figure up stuff again to get back up to this residual amount. So the residual is added to here, and then that's the resulting part of the residual, and then that goes again into a layer norm to squish the values, and it goes down to the multi-layer perceptron, which is like the typical neural networks that you see with dots and lines connected to other dots that somewhat imitate the way the human brain works conceptually. Just a super simplified version of it. And the GELU, or GELU, that is sort of like it's a lot like the rectified linear unit activation function, or RELU. The RELU, it just turns any negative values to 0. So in that list, in the residual stream, for example, of 768 values, if any of them are negative, it just turns them to 0. So this multiplies, or matrix multiplies, L2 out with this, the pre-trained multi-layer perceptron fully connected weight, and adds the bias to it right here, and that's the output of that layer. So then that goes down to here, and matrix multiplies with the projection weight and add the projection bias, and then the residual stream adds to that again, and the output of that, once it goes through however many layers there are, the result of that then goes, or whatever layer that is, or layers, the result of that goes into the layer norm, and the result of that goes into the layer norm to squish it down again. Then the output of that is matrix multiplied by the transpose of the word token embedding, so that can convert it back to sort of the way it started. Then the results of that are output as the logits or logits. So when it's training, you would put the logits into the softmax, and that would convert it into a probability distribution where the number of elements is equal to the total number of tokens in GPT-2 tick token module. So, or the GPT-2 part of the tick token module, which I think is somewhere around 50-something thousand tokens. So it would be a giant vector of 50-something thousand tokens, and the sum of the probabilities in the tokens, if it was output from softmax, the sum would be 1. So what this would do, if it's deterministic, or later, if it's deterministic, it would output the argmax down here, which this is deterministic. So to output the argmax, which is the index location of the highest value. So in this case, you don't have to have softmax, because the highest value in the logits would also be the highest value in softmax. So this just finds the highest value in this vector of the 50-something thousand floats, and it finds what location it is of the highest value, and then it appends that to the generated list. So then that list becomes like the Golden Gate Bridge spans, and so it would, the highest thing that pops out on here next was the token V. If you just simplify it to exclude spaces and think of tokens as individual words. So we put in the Golden Gate Bridge spans, and then it says, there's the end of text token right there, and it says the Golden Gate Bridge spans the. So that's what this list would now say, since that new word or token was appended to it. So then all of that loops around and passes through the raw forward again to predict the next token, which is San. Then it loops again to predict Francisco, and then Bay, then area, etc. And it'll predict 20 tokens, and the tokens aren't always words. They could be parts of words or groups of words or punctuations, etc. But just to simplify it for this main understanding, could think of it as words, or sort of like words. So once it hits this end of this range, then it drops down to here and decodes the numbers, because this generated list is actually a list of numbers that gets converted back into words. So the Golden Gate Bridge spans, and then it would put whatever token ID represents the token the, and then all that would go into the neural net again to the raw forward and predict whatever token number or token ID represents San, and so on. Keep doing that over and over. And once that list is complete, once it hits this 20 limit, then it drops down and decodes and converts back to words again. So in this case, it predicted, after putting in the Golden Gate Bridge spans, it said the next most likely token is the, followed by San, followed by Francisco, and then Bay Area, and spans the Bay Area's Pacific coast. The bridge is the world's, and then it stops right there because it hit that 20 limit. So that is how the forward pass of a transformer such as GPT-2 works. If you have any questions or comments, let me know, and thanks for watching. Please click like and subscribe.